Okay, so the topic today is releases. So we already discussed how we can control quality by checking the style of the code, how we can control it by managing dependencies and making sure the dependencies are all in order. Today we'll discuss how we release the software and what's the point of these releases. Why do we need to fix versions of our software, and what it gives us, how to do it right, and I will show you some examples using my libraries, using some products which I developed before in different programming languages, so that you understand by example how we can fix the versions, how we can fix the code with their more or less stable positions, and then give it to our users. First, a little bit of theory. So usually we develop the software continuously. So we just make changes to the source code, we make changes to the repository. Hopefully we use repository, because some teams, they even don't use repositories, they just have a collection of files and they just code in some directory where they sometimes exchange files to each other, sometimes the people even exchange emails with the patches in the emails, it happens. But a more advanced way of developing code nowadays is by using repositories, like Git, Subversion, Mercurial, whatever you like, but the Git is the standard de facto. So when you develop the code in the Git, you do it continuously. We keep making changes. People sometimes use, as you know, the master or the main branch, and they use branches for their own changes. Sometimes people use some sort of a Git flow, format where
recording in progress.
There we go. Where they commit changes to some develop branch, sometimes it happens, and then when these changes are more or less ready or stable, then they move these flow to the master branch. No matter what you use, or what is the protocol of you making changes, you do it continuously. Every day you start your working day with writing some code. The people around you do the same. You keep modifying the files, and at some point of time, your customers, your users, people who need this code, they will take it at some point of time, and they will use it. If you develop the library, for example, if you develop the package which they need, then this package they will rely on. So they will expect your package to have certain functionality, and they will get this functionality and use in their software. We don't want them to rely on something which is not completely stable, which is not, completely is not the right word here, but we don't want the users to rely on something which is work in progress. It could be something in the middle, so we're developing some feature, part of the feature is fixed, is already created, is developed, part of the feature is still in progress, and users, they may get our product right in the middle. And we don't want that to happen, because that may create confusion. They may, for example, come back to us and say, there is a bug in your software, so please fix that. And we will see that this bug is just not a bug, but just the software was not complete. So we're in the middle of developing some feature, but the user got that piece and used there. Some people believe that continuous development is a good idea. Continuous development without releases. So they say that it has to be like a flow, a fluent, a stream of changes, a stream of features and everything. So the users should be, our users should be connected to our stream flow of development, and they use whatever we have there, they just use. Some people even use modules. I don't know what's the right name in Git, I think modules as well, and they had it in Subversion before and in previous systems as well, where you just connect your source maintenance, source code maintaining system, connect your Git repository to my Git repository, and just immediately, whenever I change something, you just do git pull in your system, and you pull my changes into the piece into your repository, in the directory which stays in your repository. My changes go into your place, and you see it there. And some people believe that this is the right idea. I don't think it's right. I think the development should be incremental, not continuous, but incremental. The release to customers should happen in increments. Something is ready, we make it stable, more or less. We put the tag on it, we tag it, we label it, we name it, we explain what it is, and then we give it to our customers. It's not just me believing that. I think the majority of the software industry is about that. They're making releases, and they started making that, I don't know how many years ago, a long time ago. Before there were versions, just versions, version 1, version 2, version 3. Now we have such system, which some of you may know. It's called semantic versioning, where we give names to our release versions using the dot notation. So we have just number, dot number, dot number, dot number, and so on and so forth. Some people use many numbers, but semantic versioning is about using 3 numbers. So the first one goes for the major version, the second one goes for the minor version, and then the third one goes for the bug fix version. So let's say you release the software, you say, this is my first stable version. You call it 1.0.0. Then you make a bug fix. For example, they report you a bug and say, your version 1.0.0 is broken, so I try to use it here and there, and it doesn't work as I expect. So what do? You release version 1.0.1. So this is your first bug release. Then you release a second bug release. They again report you with the bug. You get 1.0.2, and so on and so forth. Some people even attach the labels at the bottom of at the tail of this name. They say 1.0.1 dash alpha 1 dash alpha 2 dash alpha 3, and then dash beta, and then dash beta 1, beta 2, beta 3, and then finally they get jump to the next version. This also may happen, but in general the rule is this: the first number goes for major, the second number goes for some minor change in the functionality. So let's say you release 1.00, and then you make some functionality improvement. You maybe introduce some functionality, but you don't break the functionality which existed before. So what you had before, what users were used to before, you don't touch. So you just introduce something new, or maybe slightly modify how the functionality works, but the interface doesn't change. So people don't expect version 1.0 differ from 1.1 as much as they need to rewrite the code they have. They may enjoy some extra functionality, but they don't expect some functionality to go away. So 1.0, 1.1, 1.2, 3, 4, 5, it all just increments the function, just adds more to your features. And then if you want to break something and completely remove the functionality you had before, then you release version number 2. And then 2.0, 2.1, 2.3, and so on and so forth. So basically, second number means that we don't delete anything, we just add something. The first number means we delete something, so expect when people move from version 1 to version 2, the major one, they expect some rework. So they understand that they will have to rewrite the software they have because you really have something removed. So it's called semantic versioning, semver. You can go for the website called semver.org, and you see the explanation of what I told you just. There's another idea quite popular on the market now. It's called zero versioning, zero-ver. You can go for the website called zerover.org, and you find there are people who advocate for never releasing the software with the number 1 in the first place, in the first position. So it always goes to 0 dot something, 0 dot something, 0, 0, always 0. And it's more like fun. I don't think it does. It makes like it makes sense. It makes sense on technically, because of course at some point of time you will have to release something which will break the functionality you released before. Or maybe if you follow this concept, if you go with this zero versioning principle, then you will never release any software which will delete the functionality it had before. So all of your software will basically maintain the features, maintain the functionality which you promised to your customers from the day one. So that's why zero versioning. So keep it with the 0 at the beginning, and you will never disappoint your customers. Like I said, maybe technically it's not so easy as it is said. It's not so easy to do, but it would be nice if you follow this principle. So never disappoint your customers. Keep the 0 as at the first position of your versioning. So that's the idea. The more releases you do, the more frequently you do releases, I believe the better. So keeping your software for a month without releases is a completely wrong idea. Even though some teams do that. I've seen that situations, people don't release for months, for sometimes even for years. So they just develop, and they always, when you ask them why there are no releases there, why there is no stable version, they say, we're not ready. So once we're ready, once we have something stable, we just do it, we promise you, but for now it's in development. It does make sense if you look at what they're doing, but it doesn't make sense for their users, and it doesn't make sense for the stability of development, it basically tells us that there is lack of discipline in the team. So if they have no protocol, they have no, no demand, no desire to fix their efforts at some point of time and release something, they just keep working instead of thinking of their customers and actually delivering something, then the risk of delivering something wrong, or the risk of just having something which is not possible to stabilize at some point, is very high. So I suggest we kind of enforce the team for releases frequently. At least, in my opinion, if the development goes actively in the team and there are many people in the team, I mean at least 3, by many I mean at least 3, then releases must happen every week. So you just develop every few days, every few working days, you just fix it and say, okay, that's it, time to put it there, and you just release it. And of course, the release must happen, like we discussed before, the release must happen automatically. So it shouldn't be the manual procedure. All the books, they say about that. It has to be a script. It has to be maybe a collection of scripts, but ideally it has to be one script, which is executed by some machine, some robot, not manually definitely, not somebody running the script on their laptop, somebody who knows how to do it. That's wrong. It has to be some machine. Maybe it has to be GitHub action, which does it when you create a tag, or maybe it has to be some robot, which is like our bot, which we use, Rulter, which listens to you on GitHub, I'll show you today, and just listens to your commands. When you say release, it just does all the packaging and releases. But the bottom line is that it has to be a single script, which does everything and either fails in the end or puts the product, puts the package to repository, to production, to the server, whatever. And of course, like I mentioned, you definitely attach a tag, git tag, to the release. So when you release, you must keep this information about when it happens and what was the version using git tag. So you do git tag, you tag your version in the master branch, or what's your main branch, and then you do the release, which is similar to the tag in the Git repository. First, I'll show you this small, very small Ruby gem. We discussed before what is Ruby and what are gems. So in Ruby, they call them gems. So when you package all the pieces together, then it becomes sort of a binary file. Basically, in most cases, in most package managers, in most languages, the final deliverable is the zip file, an archive, which contains all together. So in case of Ruby, then we have the gem, and each gem contains a so-called gem spec file. So I'll show you now the co-bench. This co-bench is a Ruby gem which I created a few months ago it does really funny thing, which you may, just a side note for you, which you may find interesting. So it looks like this. Let me show you. It is a collector of statistics for a team of developers. So let's say you have a group of developers, they all commit to the same repository or a group of repositories, and you want to know how well they perform. So we have about 25 or so people, and we built these statistics for them, which this gem, so you basically run this gem from the command line, you give this tool and names of the developers on GitHub, it goes to GitHub, it collects the information about those developers, like how many pull requests they did over the last, we used 28 days. So you give this configuration there, you say, collect it for me for 28 days. So it goes, and for 28 days, it collects the information, statistical information, which is open. Like this information is completely open on GitHub API. So it puts together the numbers, and then we see who is, by some factors, who is first, who is second, who is performing better, who is performing worse. So it's pretty funny to collect this information. It was always hidden for us. We didn't know who is doing what, but with these numbers, with this page, which is updated every night, we kind of have a look at who stays at the top, who stays at the bottom. Of course, we don't try to compete between just people staying close to each other, but you see I'm also here at the position 5. So, but we definitely want to see people who are at the bottom and to understand what's going on. So for example, the people who are on top, during the course of 28 working days, not calendar days, so it's basically 1 month, they do like 25 pull requests. Some of them do 30 pull requests, 17 pull requests, 26 pull requests. So basically successful about 1 pull request per day. So that's like the statistics of how people who work full-time developing software, how many pull requests they do per day. Or for example, how many issues they submit. So some of them do 19 issues, some of them do 6, sometimes even 0, some of them do, that's me, 74. So that's the amount of issues people submit to our repositories. And then we calculate the score. So we use some factors for each of the numbers. So we just put them together, multiply, and we get the score. So who is more actively performing, who is performing less actively. So to build all that, I created a gem. It's called co-bench, because of the coder, and the bench is the bench. So that's the repository. It releases to Ruby gems. The current version is 0042. You see how I named it. So 0 because it's 0. I try to use the 0 versioning for the last few years for sure. And then 42 means because I keep fixing the bugs. So I don't really introduce new features. I just keep it with 00 because it's still quite unstable, and I change it for the last few months already. So I just increment the last number, 42, 43, and so on and so forth. So let's see how the release happens. So let's say I want to release the new version. Let's say that's how I interact with my robot who does the releases. So let's release a new version. So I make a ticket, and then I start communicating with the robot, who is called Rulter. So Rulter is the automatic chatbot which I can talk to. I just post a message to the chatbot, and it will reply to me, hopefully, and then I will be able to ask this chatbot to release a new version. But in the meantime, while it's thinking about answering me, it takes some time, about a minute or so. You can see the configuration of this release. Yeah, it did reply to me. You see, it gave me the heart. It says, hi there, I understand the commands, and so on and so forth. In the repository, I have a script. In this repository, I have a script which is a configuration for this chatbot. So in the repository, I have a YAML file which configures how to do the release. The first commands I say, please take this Docker image. This is the name of the Docker image. We can change it to the latest one. That was the previous. So now I know that I have the more fresh version. So let's make this small change. Then it says what to do before doing the release. So install, run this tool, run this command, and then finally do this script. So this is basically the release script. It runs the rake is like a make file for Ruby. So rake is a tool which automatically runs all the steps, runs the unit tests, runs the integration tests, and all that. Then it replaces the version. That's an important step, which does in all release mechanisms. I believe this step must exist. So it goes to the file version here. And in this file version, we have 000. So this is like a placeholder. It's a placeholder. I use 000. Again, for the last few years, I find this the most convenient placeholder. Some people may do like this. Version, something like that. So it means like it's not a real version, but a placeholder. I use 000. I find it quite convenient to understand for anybody what's going on. So it's not a real version. So in the development, in the master branch, I have 0, 0, 0. I don't have the version. I don't know what's the version now. What happens in the script, it finds this 0, this 000, and replaces with the tag. What is the tag? The tag will be given here. So when I say router, release, and then I say tag is, and then I go 0, 0, 40, what was that? It was 43 before. So we go with 44. Let's do the release 44. So when I run this, router starts the new Docker container using this image. This is the name of the image which it will use, which the Docker which the router will use. And inside this image, inside this container, it injects the environment variable tag. And this environment variable is used here. So I take this from the environment and I replace using set command, Linux command. I find 000 in this particular file and replace it with the tag. All languages which I release, all the packages, I do the same procedure, but it may differ. It may differ in the way it's configured, but it's always the same. We need to find in the current code base, which is in the master, find the place where the version is declared, and replace it with the actual version. Then see what I'm doing. Then I add this file to Git. I mean that's just a precaution because it's already there, and then I do the commit. So I committed, but I don't commit it to the master branch because router, when it starts this process, before it starts the release, it creates the new branch. It creates the new branch by this name. So it makes me a new branch, and in this branch runs my script. So I'm already in this branch. I change these numbers to the right number, and then I do the commit, and then I package. This git build will actually build the binary, which later goes to git push. It goes to Ruby gems. So if I go to repository, for example, here, you can see that all of these previous 43 versions, look what happened before. So all of them are here. So all of them were released. So if you look at the master branch, again, this libcobench version, so here we stay with 000. We're in the master branch. If I go to the one of the tags here, so you see the numbers were replaced. So the release mechanism takes the master branch, makes the new branch named by the tag I'm trying to release now. In this branch, which is already isolated branch, it makes the changes, like making the version the proper number, setting the proper number. And then afterwards, after this will be done, a router will push it to Git repository. Because of that mechanism, I have a proper traceability of what happened before. So I can roll back, I can go to, not roll back, but I can jump to any version here by the tag, and I can see, of course, the number is here, but the code is also different there. So the code is different, and everything is by the version 0037 or whatever. So when the development goes properly, then you should be able to see the master branch in your repository and many tags which attached to all the branches which were created to make the particular release. If you don't see that in repository, then you're doing something wrong. If you don't see this track of the versions, and they don't go one by one after another, and they don't match with the, let's go to Ruby gems where the deployment happens, and let's find my branch, my gem, sorry. So here it is. You see, all these versions which were released, I can click to any one of them, and you see the 0023, and it definitely has also 0023 somewhere in this list. So what you have in Git and what you have in the repository, in the storage of binary artifacts, they have to match one to one. So let's try to do the release and see what happens. Definitely it will release, but before we release, let's make the changes. So I made a very small change here. You see, 113. I put it there. So let's So now we're in the master branch. So I'm staying in the master branch, you see. So I made just small change. I do the commit. It's a good practice when you commit, then you label your commit with the name of the ticket which you work. So let's say up the Docker image version, and then you do git push master. The GitHub will pick this up. You see, the GitHub attaches your commit. I think most of you understand this already, but still. So when you properly label your commit, when you use this marker there, then GitHub understands that this commit belongs to this ticket, and now we can go for the release. So now what happens? Router starts everything. I will show you now the log, and the product goes to production. Ruby release is simple. Ruby release is simple, probably one of the simplest release mechanisms for. Actually, the younger the language, the easier the release. I think we just learned the lessons. We now know how important it is to immediately when you design the language, just invent the mechanism of release. If you go back if you roll back the history back, then and you ask yourself how do you release, for example, C++ code, that there is no clear answer. So we don't know how to release the C library. So if you develop the C library, then we just don't know how to do it right. So there is no, to my knowledge, there is no central place for C libraries. There is no central place for the binaries which you can distribute for C libraries. People just do it somehow, inventing their own mechanisms every time. For modern languages like Rust, for example, or Ruby, they're not super young, but still much younger than C++. These mechanisms, they already built into the language. To some extent. For example, Rust is quite fresh, and they have it probably the best deployment release mechanism I've seen so far. For Java, which I will show you now in a minute, for Java the mechanism is a little bit more complex because they require they need more pieces to put together. So before you can release the Java package, you need to prepare this Java package properly. You cannot just make a zip archive, like in case of Ruby, and just put the zip archive there. It's not like that. Like really in this repository, in these Ruby gems, the stuff which they give you, you see, you can click download, and they just download the gem file. And gem file is quite simple, basically archive of everything you tell them to put there. So you just explain what to place there, which files go in, which files are executable, so just meta information, and that's it. In case of Java, we need to be more, there are a bit more steps. I'll show you now. Let's wait for this guy to be released. It takes a few minutes. And you can click here and see the log. So this is how it goes. I'll show you now what exactly is doing that. So this is the full log of the full operation. So router starts, does many steps, which quite technical. We don't need to know what's going on. But for example, it says, okay, what's the Git version now on the server? It prints us what's the version of the Docker. It gives us all the secondary supplementary information. Just step by step, it shows us what it does before it can actually start the container. Then at some point of time it starts the container. There are many operations which we're not interested in. And in the end, here, so we're close, we're in the container, and then it starts the commands which we wanted to. Look, it installs now the commands from this file. Now they start executing. So this line is here. You see? So it runs this line, installs the something. Then it runs the unit tests. These are the unit tests. It says bundle exec rake. So this is the line which goes in here. Then it runs unit tests. So now it's still running. So the log is not finished. So it's still running. We can refresh it. It will show us a little bit more because it takes a few minutes. Yeah, now it's done, I believe. Yeah, it's done, and it tells me, okay, I'm done. The full log is here. The version 0.044 is right there. So these are all the efforts which I did, and look at the end. Like I promised you, look what it does. So it does the tagging, and then it returns back to master. It cleans up everything, and then it pushes all the tags which were created. And actually, the new tag goes to the repository. And we can go to repository now, and we will definitely see this new tag. 44 is right here. And we can go to Ruby Gems. And if I reload it, you see the version is 44. So all I did, you just saw it, that was all my efforts. I just gave one command here, and everything happened automatically. So ideally, you should configure your software repositories the same way. In my experience, 99% of people who I know, they don't do it. If you ask yourself, if I ask people around me, how do you release? They will say, I have a script, I know how to do it. There are a few clicks here and there. I just know where my files are, and it just happens. For example, look at these Ruby gems. In order to release to Ruby gems, you need a password, you need credentials there. So you need to authorize there, you need to connect, to log in, to do all that stuff. I don't have this information on my computer. I don't hold it on my laptop. I just did one command, and it happened automatically. The credentials, they came from here. So this special file, Ruby Gems YAML file with the credentials to the deployment platform, it just came from here, from this repository, which is private, my repository, which is private, and in this repository there's a directory, and in this directory stays this file. So Rulter just took that file from there, and using this file was able to deploy to production platform. For most people who I know, this file they keep in their local computer, and they use it. And if you remove that person from the project, then the project doesn't have this information. And that's wrong. So we have to, when you configure the release procedure, you have to think how it will work without me, when I'm out of the project, when I'm not here anymore. So what will happen, how they will do it. And that's actually a recipe for a healthy life for you as a developer. Because you will not worry about the future. Like this repository, I'm working with this repository now. I do releases maybe like every few days. But I have some repositories which are 5 years old. And I don't release them at all, I mean, for 5 years. Then I go back to them, and I can just click really give one line to this chatbot, Rulter, and the release happens. So it's easy to say, of course, I mean, all the books, they say that, but in reality, people don't do that. Why they don't do that? Because it takes time, because it's quite a lot of work. So when the product is easy like this one, like the Ruby gem, which is quite simple, then automation may look simple. But sometimes the products are bigger, sometimes they require more configuration, and people just get lazy and they think, I'm not going to do that because from my console, from the laptop, I can just release in a few seconds because I configured everything, I already installed everything. For example, I need this dependency, I need that dependency, I need that dependency. They're all installed on my computer. I already invested a few days of work to configure everything, and that's why I can release from my laptop easily. And of course, it's difficult to create a script which will install everything again on a clean Docker image, for example, clean Docker container. It will take some time, and it's a painful operation. It's not so easy to do. And people get lazy, they just don't do it. In the end, they pay, either they pay with hours of work every time they need a new release, or they just, at one point of time, they just abandon the software and just say, I don't remember how to release that, let's start from scratch. And when the product moves from one team to another, you know, some time ago I was doing audits of software teams. So sometimes they ask me, some friends, some people who know me, they just come and say, can you audit the team, not the team, but the product. So we're developing something for a few years, we have a team of programmers, so how about you take a look at what's going on and give us your opinion, like, is it okay, what are the problems, the technical, audit, it's called the audit, and people do that. So the first step I do, when I do the auditing, I check where is the release script. How do you release this software? And if I don't find it, it's already for me a red light, a red flag that something is wrong with this team and something needs to be fixed immediately. But on the other hand, if I see that complete automation is in place, then it tells me that the team is professional, and I have like a positive attitude to everything now, to the code, to documentation, to everything, because I believe that they think about that. I see that they think about this, they care about their release procedures, and that tells me that they're good programmers, so to speak. So a few thoughts about Java release. So when you release the Java, I can show you how it happens in Java, which is a bit more complicated. For example, we have this framework, and the release script looks quite similar, also not large, it's not huge. Again, we have the Docker container, a bit more assets here, so we not only need password to put it to Maven Central, so-called. It's the place where you put the Java artifacts, but we also need two keys. We need these PGP keys for signing the artifact. I'll explain you now what it means, and then the release happens again. So again, we change we change the number of the version inside the code, but now it's done not with the set command, but with the Maven. So Maven has a built-in feature for changing, it has a plugin for changing the version inside in the POM file, which Ruby, to my knowledge, doesn't have, so that's why I have to use set. But the logic is the same. The logic is the same. Here we check that the tag provided, it's quite a good check, by the way. I don't have it here for some reason, but I must. Yeah, it would be good to put it here. So this line basically checks that the tag which is flying to me from GitHub command actually matches the Semver format. So the number goes first, and then another number. Oh, actually, you see there's many of them. It's probably not the best format, but basically it says that has to be number, dot number, dot number, any number of numbers. But it's better, of course, to say that there are only 3 numbers here. So instead of doing this, we should put it like that. That would be more strict. So every time the user tries to release, that's like for the future. Let's say I give this repository to somebody else, and in a few years that person will decide to make a release. And the person will say, instead of saying router, instead of saying like I did here, the person will do like that, which is not the Semver format. So Semver expects this, semantic versioning. But the person will do this, or even like this. I don't know, 44, and they will do 45 by mistake. So this mistake, somebody has to catch that mistake. So in order to do that, we sometimes use this command, which is checking the format of the tag using regular expression. And if the format is wrong, then this one will not go through. So the release will not happen. But now I don't have this line here in the co-bench. So that's why this line will actually fly through. That's not good. Anyway, getting back to Java release. There you go. So the logic is the same, but Java takes more. It's more complex. The release is more complex in case of Java. Java not only packages the piece of code together in a zip archive and then send it to Maven Central. It expects this package, which in case of Java is a jar package. It's also zip archive, but it's called jar. So the jar has to be accompanied by, first of all, by the Java doc package. So Maven Central, they expect us to put next to our jar file another jar file with the Java doc. I can show you what it means in reality. It's exactly the same repository I showed you. So this is takes, that's the one we develop. So let's take one latest version, 32. 0, oh, we have 1.9.2, okay. So this is what we need to prepare before we send the code to Maven Central. In case of Ruby, it's just one file. In case of Maven, it's, you see how many files? I don't know, 1, 2, 3, it's like 16 or something. So, yeah, 16. So they expect the main file to be there, with the actually compiled the binary code. Then they expect the POM file. POM file is a text file, the XML file, which is the same XML, which is like a meta information about everything. Then they expect the sources to be packaged, so the Java files, not only binary class files, but also Java files here. And they expect the Java doc also to be in the special archive. And for each file, they expect 3 supplementary files. ASC means the public signature of the person who signed this deployment. So this is my signature, this is me. So they will be able to kind of in the future verify, so who was the guy who signed that. Actually, this is good idea for the users. So if the user, for example, says, I'm going to use this library, this open source library, and I trust this library, and I trust this library because I know who is the developer of the library. And you know there is a huge problem on the market with this open source, the open source, with the trust in the open source territory. So people kind of stop trusting open source massively now, because before we had this trust, so we knew that people, it was some sort of a trust in the open source. So we knew that people who develop open source, they have the best intentions. So they try to do the best. They develop the software not for money, so they don't want to do harm to anybody. So we just take that code and use it. And then we take another code, the new version, and we use it again. And as soon as they upgrade the version, we believe that they do it because they want to deliver new functionality. So we just take new versions, whatever it is. Now the situation is a little bit different, and some people start incorporating some they call it what's the right name for it? Not malware, but I don't remember what's the name of it? Spyware, yeah, something like this, spyware, yeah. So they inject the code in the open source. So first of all, they develop the open source library for years. And we start trusting them. So we know we use this library, we don't really have any reason to not believe that this library is something wrong. And then at some point of time, their situation changes and they want to do some harm. For some reason, for political reasons, for technical reasons, I don't know, people are people. And they inject some code in there, and then we just take that software, and all of a sudden this spyware is right inside our code, because it arrived together with the open source. So how to fight with this problem, it's still an open question. So we don't know what to do, what's the right way to deal with that problem. But another problem which is related could look like this. It was some open source product which was developed by somebody, and then something changed and the team changed and there are different people there, or maybe the different storage which contains these files. So we don't want to take them blindly. We want to take them as long as the file is still released by the same person. So for example, this takes framework, it has this signature attached to it, which belongs to me. So the users who use it, they trust that guy, so they say, okay, we're gonna take the code as long as this signature is there. So if somebody else will release this code, for example, I quit the project and somebody else joins the project, they change the signature, they release with their own signature now, then the user might say, we need the extra validation step, we need the extra verification, who released that, why the team has changed. They will understand it if the signature gets changed. Maybe this is important here because in Maven Central they don't have accounts, because in case of Ruby gems we know exactly, well actually, yeah, here I think it's obvious that who is the owner, because the Ruby gem is connected to me, and when you use it you know exactly who is the owner. And if you see the new version released here, then you will see, look, yeah, you will see that pushed by, so you see who pushed that version. So you know who exactly was the author who delivered the version. In case of Maven Central, you don't have this information here because it's like there's no place where you can see who is the owner, who pushed that stuff. It's just right there. In order to make it more identifiable, then that's why they have this file attached to each file. Also, they have this MD5 of the file. That's for double verification, and also SHA-1, also another hash code for the deliverable. But what's important here, of course, is there are just 4 files, not just one, but they want it from 4 different perspectives: the sources, the Java doc, the jar, and the POM.